In this video, I'm going to be looking at Newton's second law of motion, F equals ma, and provide some exam style questions by discussing in ways such as qualitative descriptions, graphs and vectors, and deriving relationships with F equals ma. In my previous videos, I have looked at Newton's first and second law in depth in A, B, C, D kinematics videos in my playlist on dynamics. So have a look at my kinematics and dynamics playlist, and if you already haven't, please subscribe. I've been doing a load of videos of this new physics course. Alright, so let's have a look here. F equals ma. You would have learnt this maybe in junior science, where F is force and it's a vector quantity, so it needs a direction. M is mass, and it's in kilograms, and A is acceleration, and it's a vector quantity as well, and it's in meters per second. So when there are an imbalanced force acts on an object, it produces an acceleration that is directly proportional to the force and indirectly proportional to the mass of the object. And you can see that with the flow chart. Now let's have a look here at a few questions. So find the force of a 5 kilo mass which accelerates for 3 seconds. In this time, its velocity changes from 2.5 meters per second east to 17.5 meters per second west. So what equations can you possibly use? Now you would have recalled that V equals U plus AT in our previous module, kinematics, and you need to rearrange to find A. So you got your top line as minus 17.5 to minus 2.5 divided by 3, and I'll give the acceleration as 6.67 meters per second west. Now let's have a look here at F equals ma. Now you insert the acceleration got given and give it a negative value because it's going west. So 5 times the negative acceleration value, and you'll get a negative force of 33.33 repeated newtons, or 33.33 newtons west. Now that's pretty self-explanatory, as long as you give west a negative value or south a negative value and north or east a positive value when you're doing these equations. That is, work out the final answer and directions. Let's have a look at another question here. So after 4 seconds of accelerating at 2.5 meters per second, a 500 kilo car moves at 50 meters per second east. Now, calculate its initial velocity if the acceleration is positive. What happens if the acceleration is negative for B? Now, C, calculate the force acting on the car if the acceleration was positive, and D, if it was negative. So let's have a look here. You've got the same equation, V equals U plus AT, and rearrange that to find U. However, you need to make sure that your acceleration for A is positive, so you see that as 2.5, and for B is 0.5, which will change the answers slightly. So U equals 40 meters per second east, and for A, and for B, it is 60 meters per second east. Now let's have a look at C and D now. So you're using FMA, and remember that you have to have a positive acceleration, negative acceleration. F equals MA, you have 500 times 2.5 for C, or 500 times negative 2.5 for D, and that will change the answers as well in its direction. So let's have a look here. You get your answer for C as 1250 newtons with the motion, and for D, negative 1250 against the motion. Okay, can you see how vital the symbol is in front of the acceleration, mass, or force can play in our final answer? Now, I hope you enjoyed watching my videos. I've been making a whole playlist on kinematics and dynamics. I encourage you to subscribe again because there'll be a load of videos for the Module 3 and Module 4 coming up in the next few weeks. Thank you for watching.